Okay. Hello, I'm Kennedy, and this is the imaging and microscopy facility. These are the different instruments that we have in our facility, and the different PIs that had different grants that allowed us to have these different instruments within our facility: CEM, SEM, XRD, XPS, all that stuff. So let's take a walk inside. I'll show you where all the instruments and which room they're. So in the first room, this is for sample prep equipment. So we have like a gold coater, different sample preparation equipment you can use to prepare your samples for TEM, SEM, XPS, or whatever you need. Okay. In this room, this is where we have our Zeiss SEM for Gemini 500. Okay. This is our one of our SEMs in the IMF facility. SEM is scanning electron microscopy. This, you can see we have the setup here has a gun, sample chamber here, and then all the instrumentation down here. This is a view of what it would look inside. Sample chamber, you'd have your sample stubs here, and then you have different slots where you can put your sample stubs. So this is an example of what the sample stubs would look like. They're on the aluminum stubs. They could be different sizes. This is just one of the standard sizes that we use. To use the SEM, it needs to be in a vacuum environment. It has to be electrically conductive and grounded. So one of the ways we look at certain samples, like leaf samples, we would ground them. We have carbon tape to ground the sample, and then we also coat it with gold, a thin layer of gold, so then we could analyze the surface morphology of the sample. So here's an example. This is a leaf sample. Normally, if you blast electrons on the leaf, you may degrade it because you're using electromagnetic radiation on it. But with the gold coating, it protects the layer, and then also it mimics the surface of the sample, so you can see the surface morphology of the sample there. So just different examples here of the different kind of pictures you could get. You can see the scale bores at 200 nanometers, 100 nanometers. You also get micron resolution. Okay. In this room here, this is where we have our XPS for X-ray photoelectron spectrometer. We also have a confocal microscope as well. Okay. This is our XPS machine. It's an X-ray photoelectron spectrometer. So we have a sample holder. We clamp different samples on the sample. As you can see here, different samples on the stage, making sure nothing touches, so it has the proper height, and then we can put it inside the instrument. Just like that. This is an example of the interface of the software. You get your sample here. There are different types of ions for this. So we have an ion gun for etching the sample. We have a Raman spectroscopy for checking the Raman spectrometer on the sample. We have an X-ray source that is for getting our XPS signal. We have a UV source as well, and we have a flood gun. So for XPS, the purpose of XPS is to analyze the chemical properties on the surface of the material. We have the flood gun is to blast electric current onto the sample, so you can analyze non-conductive samples. If you have a metallic sample, then you wouldn't have to use the flood gun. UV source, if you want to analyze about 3 to 7 nanometers layers of the surface, if you want a thin layer. X-rays, the X-ray to analyze maybe the first 10 nanometer thickness of the surface. Raman spectroscopy, pretty similar. For the ion gun, that is if you want to etch the surface to remove different layers. Say you have a sample and you're interested in if you did a certain treatment on it and you want to see how the top of the surface of the sample is different from, say, the top 10 nanometers versus the bottom 10 nanometers, so on and so forth, you would etch the sample, remove the first 5 nanometer layer, analyze the surface with X-rays, etch another layer, then you can analyze a depth profile of how your sample looks based on your treatment. You can see what kind of elements are present, what kind of potential bonds there are present as well. And that would be our XPS instrument. This room is where we have our TEM. This is our TEM, Transmission Electron Microscope. It's equipped for cryo TEM, so you can look at biological samples. It's also equipped with an EDS, Energy Dispersive Electron Spectrometer, so then you can also look at the chemical composition of your sample and where it's spatially located on your sample as well. So TEM, similar to SEM, it requires a vacuum environment, has to be conductive, has to be grounded. The thing with the TEM, it's transmission, so the electron beam has to penetrate through the sample. So when you prepare your sample, you're going to need the sample to be less than 100 nanometers thick. And then practically, when you actually analyze the sample, it has to be even less. So usually your sample will be between around maybe between 2 to 15 nanometers. If you're looking at bigger samples, you can probably look at 50 nanometer particles, but I wouldn't look at anything that's greater than 100 nanometers, because in the TEM they'll appear completely black. If you want to see through them, then you'd want them to be less than 100 nanometers. This is an example of one of the sample holders you would be using. At the end over here, this is the sample is on a 3 millimeter disc, so you can see how small the sample could be. You could put powder samples, or if you have a metallic sample, you'd have to cut it into a 3 millimeter disc. There's different sample preparation equipment you could use to break down the sample that small, and then you'd have to thin down the sample enough. There's several different techniques you could use to make it super thin. The easiest way to do it is to have a 3 millimeter copper grid, a thin carbon film on it, and then put your powdered samples or grow your different particles on the grid itself. Put it in the sample holder, put it in the TEM, and pump it down, then analyze it in the TEM itself. Okay. And then this is where we have our X-ray diffractometer. Okay. This is our X-ray diffractometer. So we have this is sample disc. We have to make sure the sample is flat and smooth. If you have powder, you put your powder on it, then smooth off the surface. We have different tools. So flatten the sample surface to make sure it's flat. You wipe down the surface as you need. There are different sample holders that we could use. And then, so for XRD, we would analyze, this will be the surface funnel, and then when you analyze the sample, you'll get different peaks, and then based on the peaks, this is like your fingerprint of your sample. They will only show peaks if they are crystalline materials. So if you're looking at iron, you'll show like the different peaks that are represented for iron. Different crystalline materials will be useful to be seen using this technique. If you have nanoparticles, you could also look at nanoparticles. You won't get sharp peaks, but you'll get broad peaks depending on the size of your nanoparticles. So this is just how you would analyze mostly crystalline materials. If you want to know whether the sample is crystalline or not, if it's amorphous, it would show an amorphous peak, and you could also analyze that as well. This is more for something you would, if you want to know what the crystal structure is. And this last room here, this is where we have our environmental scanning electron microscope. So this is the other SCM we have in the IMF. This is our environmental scanning electron microscope. The difference with this microscope and the other microscope is this is for, you can use this for more for environmental samples. And in this case where you could do, you could add humidity into the chamber, change the pressure, so it doesn't have to be completely at vacuum, but at low vapor pressure, so you can look at how the sample looks like when it's wet, So this will be great for leaves, some potential biological tissue that say if the tissue you can't gold coat it like in the other instrument to view at it. You want to retain like as close to the natural environment as you can at a different pressure. So then you can view it using this instrument here. This instrument is also equipped with an EDS detector in the back over here, in the black box there. It can analyze the chemical properties, the chemical composition of the sample, and then if you wanted to take a picture of your sample on the micron scale, and you want to know which part is gold, which part is copper, which part is this will be very useful if you're looking at a silicon device, where if you coated and did different fabrications on the device, you want to know where the aluminum strips are, where silicon connects, and all the interfaces. You could use this instrument as well. You can also analyze different environmental samples, what kind of air pollutants, as long as there's sample size on the micron scale, maybe on the nanoparticle size as well. Okay, thank you. I hope you enjoyed this virtual tour of the IMF facility.